Welcome to 1.5 division of real numbers. Here we have our first example. Even though it's in parentheses, it's emphasizing that it's a positive 72 divided by a positive 6. That's all it is. Now, just like in the last section, I know write out that this is positive divided by positive. Our final answer should equal to positive. Now, when we have a division problem like this, what I'm going to do is set it up like how we did in middle school math and algebra 1, algebra 2, and even in geometry. So, the second number will go on the outside, and then the first number will go in the inside of the division house. Next, we check and ask ourselves, does 6 go into 7? And it does. It goes into 7 one time, so I'm going to put the 1 on top of the 7. I do 1 times 6, which is 6, parenthesis, subtract, 7 minus 6, that's 1, and then I bring down the 2, making it 12, and then I ask myself again, does 6 go into 12? And it does. It goes into 12 two times, so I'll put 2 on top of this 2 right here times 6, that becomes 12, parenthesis, subtract, and 12 minus 12, my remainder is 0. The reason I said remainder because there's no more numbers to bring down. Since my remainder is 0, our final answer is 12, so 72 divided by 6, or should I say positive 72 divided by positive 6 equal positive 12. And that's our final answer. In example 2, we have a fraction where it is 108 over 9. Now if I rewrite it as a division problem, it is the same as positive 108 divided by positive 9. Alright, so just like the first example, so again, it's a positive 108 divided by positive equal to positive. The checking the sign is the same application when it comes to multiplication. Now it's set up just like before. What's my second number or what's my bottom number, the denominator, goes outside. What's my first number or what's my top number, the numerator, goes inside the division house. Now I check. Does 9 go into 1? And it does not, because 9 is greater than 1. So if I want to fill in the space right here to properly align my numbers, that's okay. You can, and you're allowed to put a 0 if you like. Instead of using 1, I'm going to connect it with the 0, making it 10. Does 9 go into 10? It does. 1 time. 1 times 9 is 9. Subtract, so 10 minus 9 is 1. And then I bring down the 18. Sorry, the 8, making it 18. Now I ask, does 9 go into 18? It does 2 times. So put a 2 on top of the 8. 2 times 9 is 18. Subtract. 18 minus 18 is 0, so therefore my remainder is 0 because there's no more numbers to bring. So our final answer, it will be 108 over 9, or divided by 9, equal to a positive 12. So this is our final answer. Example 3, we have another fraction, 11 over 4. If you were to rewrite it as a division problem, it's just 11 divided by 4. Next, I'm going to check the sign. So it's a positive divided by positive, so our final answer is positive. Alright, I'm going to set it up. What's our second number in division, or our denominator in the fraction, goes outside. What's our first number in division, or the numerator in the fraction, go inside. Alright, now check. Does 4 go into 1? It does not, so I'm going to put a 0 on the first one, and then I'll bring the second number, making it 11. Does 4 go into 11? It does. It goes into 11 two times. So 2 times 4 is 8. Subtract, I have 3. Alright, 4 does not go into 3. So what happened is, I'm going to keep going. And in any event you have to keep going, that means it's going to be a decimal. So I'm going to put a decimal right here. I'm going to add a 0. I'm going to bring down the 0. So instead of 3, it becomes 30. And I ask myself, does 4 go into 30? It does. 7 times. So 7 times 4 is 28. Parenthesis, subtract. 30 minus 28, that's 2. I still have a remainder. I'm going to keep going to see if I can have a remainder of 0. So I'm going to add another 0 here. I'm going to bring it down. So instead of 2, it would be 20. Does 4 go into 20? It does. 5 times. So 5 times 4, that's 20. Parentheses, subtract. 20 minus 20, that's 0. So my remainder is 0, so that means I can stop. So 11 over 4 equals to a positive 2, don't forget your decimal, 0.75. Now to review, the reason we have decimal is because when we divide the original number, which is 11, we had a remainder of 3, so I added a 0, and when I do that, I put a decimal in front of the 0 that I added. And I continue dividing until I have a remainder of 0. That's why I stopped after the 5. And our final answer is positive 2.75. For our fourth example, we have negative 34 over 8. I'm going to rewrite it as a division. Now, in the event you do have a negative, I want to have the negative be with the first number, or the numerator. So it's going to be negative 34 divided by positive 8. Check sign for our final answer. So negative divided by positive, our final answer should be negative. So just like multiplication, when it comes to division, we're just going to focus on just the numbers. So what's our second number, or denominator? It goes on the outside. What's the first number, or the numerator? Goes on the inside. Alright. Checking with the 8. Does 8 go into 3? It does not, because 8 is greater than 3. So put a 0 on top of the 3. Now I'm using a 4, so it's going to be 34. Does 8 go into 34? It does. So 8 can go in 34 4 times. 4 times 8, that's 32. Subtract. 34 minus 32, that's 2. Alright. Since I have a remainder of 2, I'm going to keep going and see what happens. So since I'm going to add a 0, I'm going to also have to add a decimal. Bring down the 0, making it 20. 8 does go into 20 2 times. 2 times 8 is 16. So 20 minus 16 is 4. Alright, I have a remainder of 4. That means I'm going to keep going. I'm going to add another 0. I'm going to bring it down. Instead of 4, it'd be 40. 8 does go into 40 5 times. 5 times 8 is 40. Subtract remainder is 0. So that means I can stop. So negative 34 divided by 8 equals, remember my final answer has to be negative, negative 4.25. So that's our final answer. So again, example 3 and example 4, I was able to stop dividing when I reached a remainder of 0. But in any event, you keep going. If it is repeating, then that's where you know you can stop, because the longer you continue dividing, you're going to end up getting the same number over and over at the top. So if you do, you can stop. You don't have to keep going 10 times, you don't have to keep going 20 times or 30 times. Just enough that if you see it's repeating, then you have enough information where you can stop and then in your work and then just approximate to, depending on how many numbers you have after the decimal.